Hello, my name is Daniel Apuan. I'm a member of the CU Boulder Neuromechanics Lab, and today I will share with you some of our recent work that I completed with fellow grad student Garrick Brenning on the influence of reward prediction error on reach vigor. But first, let's start with an example. You and your lab go out for sushi and get a sampler platter with many kinds of rolls. When you reach for a piece of sushi, chances are you have some level of expectation of how good it will taste. When you bite into it, expectation will meet reality. What happens then? Was it better or worse than your expectation? Will your experience of this piece of sushi impact how you reach for the next piece? The difference between reality and expectation is what we call a reward prediction error. It can be positive, getting something better than expected, or negative. Today I'll be discussing how RPEs are helping us understand control of movement vigor. To start, we'll look at how reward influences vigor. Previously, former lab member Eric Summerside demonstrated that when reaching to a target that was consistently rewarded, as shown left, subjects on average reached faster to rewarded targets than non-rewarded targets. This demonstrated that expectation of reward influences movement vigor. More recently in our lab, Shruti Sukumar demonstrated that experienced reward or reward history also modulates movement vigor, where on average, subjects reached faster to the same reward when their history of reward was greater. However, in both cases, subjects knew what reward they were going to get. So we wanted to know how subjects would behave when something unexpected happens. And so we asked, does recent reward history affect movement vigor, and does reward prediction error affect movement vigor? We then hypothesized that movement vigor will increase with recent reward and will scale with reward prediction error. To answer these questions, subjects made planar arm reaches on a kin-arm robot. Trials began when subjects were in a gray home circle and a target would appear. They would then move outwards towards the target, where they either were rewarded with a pleasing tone and a flashing target, or not rewarded with a gray circle. They would then return to the home circle and start the next trial. These targets were probabilistically rewarded across 4 blocks. Shown here is block 1, where subjects were rewarded 100, 66, 33, and 0% of the time. On subsequent blocks, the location of these probabilities have changed, but these same 4 probabilities were used in each block. So to review, subjects would reach towards the target where they experienced some form of reward. This in turn produced a reward prediction error, which we can now express mathematically as the difference between the experienced reward and the expected value of reward. Where the expected value is the product of the value and probability of reward. For a trial that's associated with 66% probability, as shown here, when the subject reached and in fact experienced reward, we can see that their reward prediction error would be 1 minus 2/3, or 1/3, which is a low positive reward prediction error. If they were not rewarded, the RPE would be 0 minus 2/3, or negative 2/3, which is a high negative RPE. We can also do this for 33%, where they would have either 2/3 a high positive or negative 1/3 a low negative RPE. Finally, while there are many ways to define movement vigor, for the purpose of this presentation, movement vigor will be considered as the peak velocity with which a subject reached. Additionally, as shown in this velocity profile, subjects had both an outward peak velocity and an inward peak velocity on each trial. Specifically, we will be looking at the change or difference of outward peak velocity between trials and the difference between the inward and outward peak velocities. And we'll start by looking at how movement vigor changed following rewards. Here on our y-axis is the change in outward peak velocity from trial to trial. When subjects were rewarded, shown right in blue, their vigor overall increased. However, when they were not rewarded, their vigor decreased. So returning to our hypotheses, we can say yes, movement vigor increased with recent reward. Let's return to this difference in outward peak velocities But now instead, look at how our RPEs impact this. First, we'll see that for high negative RPEs, subjects slowed on the following trial. However, for high positive RPEs, subjects increased their vigor on the following trial. When we add in the low RPE values, we can see that in general, subjects' vigor changed with respect to the degree of RPE that they were seeing. And this was confirmed by a linear mixed effects regression. Now we will look at how the movement immediately after the RPE changed. So this time, our y-axis, instead of being trial-to-trial differences, is the difference between the inward and outward movements. First, you can see that for negative RPEs, subjects slowed down, but there was a scaling effect of high and low RPE within this negative. This is also seen in the positive RPE conditions. Therefore, we can conclude that for all return movements, regardless of RPE condition, subjects slowed down on their inward movement. Secondly, we can also say that subjects slowed less with increased RPE. Given these results, we can say that subjects did, in fact, scale their vigor with RPE. In conclusion, we demonstrated that subjects increased their movement vigor following reward, while also decreasing their movement vigor following a lack of reward. This change also scaled due to the differing degree of reward prediction errors that were experienced. Finally, I'd like to thank the committee for selecting my abstract, my advisor, my lab, our funding source, and my collaborator, Dr. Garrick Brenning, and you for your attention. I look forward to your questions and comments during the live session. Thank you.